In this last video for chapter 11, 11.7, we're going to talk about surface area of cylinders, surface area and volume of cones. So again, I think we talked already about surface area of cylinders in a previous slide, in one of the previous lessons, yet I don't believe we ever did any problems on it. Or maybe we did actually. But anyway, we're going to just continue with that in this section. So I think this is just a review here. So again, the surface area of a cylinder, if you think about it, a cylinder has an area for a base, another base up top, and it has the lateral side. It has a radius and it has a height. And so when we're doing the surface area of our cylinder, we have to think about what that cylinder looks like if we were to open it up and, turn it into like a net, right? We know that this is one base, this is the other base, and we know that all of a sudden we end up with a rectangle is the lateral area of our cylinder. So again, the rectangle is going to be this, whatever this height is, and the base of our rectangle is going to be the circumference of the circle. And so we know the circumference of a circle is 2 pi r. And so the area of the base here is pi r squared. And there's two of them. So this lateral area of a cylinder is going to be, the area of this rectangle. So it's going to be 2 pi r times h. The total area, or the surface area of the entire cylinder, is going to be twice the area of the base, because there's two bases, plus the lateral area. So let's expand this out, right? The area of the bases is pi r squared, since it's a circle. And the lateral area we already determined was 2 pi r h. So this would be the formula for the total surface area. 2 pi r squared, meaning twice the area of the base. And then this is the lateral area here with this. And so this is where it all comes from. So again, if we come over to here in this picture and we ask you to use the diagram to find the area of the base, the lateral area, or the total area or surface area, again, we know the area of the base here. It's a circle with a radius of 5. So we know the area of the base is going to be pi r squared, because it's a circle, and it's going to be pi times 5 squared, or 25 pi centimeters squared. When we do lateral area, we know that the lateral area is going to be the circumference, 2 pi r, times the height. So here, since r is 5 and the height is 7, we've got 70 pi centimeters squared. And the total area is going to be 2 times the area of the base plus the lateral area. So the area of the base is 25 pi, the lateral area is 70 pi, and so together we've got 50 pi plus 70 pi, and we've got 120 pi centimeters squared. And you can leave the answer in terms of pi. If you guys remember, this is the same problem we did on a previous slide in a previous section. But again, that's how you solve it. Okay, now we're going to cones. So when we get to cones, again, we really want to learn about the different parts of the cone, right? Because again, if I'm doing volume of a cone, that's easy. The volume of a cone is like a pyramid. 1/3 area of the base times the height, and the area of a base is a circle, so it's pi r squared h. And so the volume of a cone is super easy. The surface area of a cone becomes a little bit more complicated. So we've got to understand when we're doing surface area what the parts are. So again, we know here's our base. Here is the height of our entire cone, right? Now this like triangular part, this is called the lateral surface. And if I were to do a cone, that lateral surface looks kind of something like that. Okay, so it's kind of a weird shape. It's curved and whatever. And then the other thing we need to know in here is we have our height, which is our altitude, or the height of our cone, which is at 90 degrees. And then we have this slant height, which is this angled height. And again, this slant height is represented by the letter L in cursive. All of these variables, okay, this height here is H, area of the base is B, this is R for the radius. All those variables are going to come into play when we find this, area and volume. So the lateral area of a cone is known as pi r times the slant height. So again, pi r in slant height. Oh, and this is the net of a cone. That's what it looks like, actually. The slant height's a little different than the one I drew. And then we have the surface area of a cone is going to be pi r squared. Notice that's the area of the base plus the slant height. Okay, or not the slant height, but the lateral area rather. Okay, so again, the lateral area is pi r L, so that's where that comes from. So again, it makes sense that the surface area is the area of the circle base and then the area of that triangle shape. So, and then we get to volume. So the volume of a cone is, again, like we talked about, 1/3 area of the base times height, or we can expand it and write in the area of the base is pi r squared in there. And again, we're going to now solve some problems. So now we come here and it wants, find the figure. So we've got a cone, it's upside down, but it's the same thing. We see that the radius is 5, and the 8 here that they gave us, well, this is the slant height. So the slant height is 8 meters. Now, we know that we're going to need the height of this shape at some point. We'll notice that the radius and the slant height and the height form a right triangle. So you know that you can find the height by solving for using the Pythagorean theorem. You know that 5 squared plus the height squared is going to equal the slant height squared. Notice the slant height is the hypotenuse. So 25 plus height squared equals 64. Height squared equals 39. And the height equals the square root of 39. So I know that here in this problem, the radius is 5, the slant height is 8, and the height is the square root of 39. So now I should have all the information I need to answer these questions. The area of the base is pi r squared. Since r is 5, it's going to be 25 pi, and it's meters squared. So there's the area of the base. The next part is the lateral area, which we know is pi r slant height, right? So again, I come over to here, r is 5, and the slant height is 8. So the lateral area is 40 pi meters squared, right? So the total surface area is the area of the base plus the lateral area. So it's going to be 25 pi plus 40 pi, or 65 pi meters squared. So that's my surface area of my cone. The last question is the volume of the cone. And remember that that's 1/3 area of the base times the height, or 1/3 pi r squared times the height. So here I've got pi r squared is 5 squared, and my height we figured out is the square root of 39. So I've got 1/3 times pi times 25 times the square root of 39. So it's going to be 25 over 3 pi times the square root of 39 meters squared. Now at this point, I probably would want to just use my calculator and come up with a better number for this. Like, I don't like having the pi and the radical and all that. And when I do all the math, I end up getting 163.5 meters squared. Or cubed, actually, because it's a volume, right? So again, surface area is going to be all squared, and volume is going to be cubed. So again, I did I basically did 1/3 times pi times 25 times the square root of 39, and I got that answer. So it's 163, not, yeah, that's it. Again, we're going to do the same strategies here. We're going to answer all these questions. So if the diameter is 24, I know that the radius is 12. So r equals 12. My slant height is 13. And again, I know that the height, the slant height, and the base here, the radius, is going to be a right triangle. So I can use the Pythagorean theorem. If I remember my Pythagorean triple, I know that the height is going to be 5. For those of you that might not have memorized that, again, I know that 12 squared plus h squared equals 13 squared. 144 plus h squared is 169. H squared is 25. That means h is 5. And so again, if you do the math, you're going to get the pieces. So again, I've got this, and now I'm going to go piece by piece. So the area of my base is pi r squared. Since r is 12, it's 12 squared, so it's 144 pi meters squared. This is the area of my base. The lateral area is pi r L. And so again, I've got pi times r times L, which is going to be 12 times 13 is 156 pi meters squared. The next one I'm going to do is my surface area. I know it's the area of my base plus the lateral area, so it's 144 pi plus 156 pi, so that's going to equal 300 pi meters squared. And that's the third thing. And then the last thing is my volume, which I know is 1/3 area of the base times the height. I know the area of the base is pi r squared because it's a circle. And I've got my height. And so again, I'm just plugging in. So 1/3 times pi times r squared, which is 12 squared, times the height, which we concluded was 5. So I've got 1/3 times pi times 144 times 5. Now for me, how I do it in the calculator is I do 144 times 5 times pi. I get this answer and I divide it by 3, which is the same as multiplying by 1/3. And I get 753 or 753.98 or approximately 754 meters cubed this time, because again, I'm talking about volume. And so that's how you solve it. You just find your missing pieces. You need to know for surface area, you need to just know your radius and your slant height. For volume, you need to know the height. Again, now finding the volume of a similar solid. And once again, remember that the volume of a similar solid, you're going to find the ratio of the radius or the height or the slant height or some measure of length. In the original, I'm going to do the small to the big, like I'm going to do A over B. And I've got that the radius is 3 and 9. So the small radius is 3, the big radius is 9, which means the ratio is 1 to 3. So I know that the ratio of the volumes is going to be 1/3 cubed, which is 1 over 27. So this is the ratio that I'm going to use for the volumes. So I know the small volume is going to go on top, and the large volume here, volume of B, is going to go at the bottom. So if I do my cross products, I should get my volume of B. So I'm going to get 27 times 15 pi equals the volume of B. So 15 times 27, and I'm going to get 405 pi feet cubed is my volume of cone B. And that's the answer. So it is 405 pi compared to 15 pi, and it's basically going to be 27 times bigger than 15. Now again, we have a composite shape. Again, notice you have a volume of a cylinder plus the volume of the cone is going to equal the volume of the shape. So the volume of the cylinder is going to be the area of the base times the height, which is going to be pi times r squared times the height of 10. So it's going to be 9 pi times 10, or 90 pi. And then the volume of the cone is going to be 1/3 the area of the base times the height. So again, in this particular of the cone, now the cone is going to have the same radius, but the height is a little bit less. So it's going to be 1/3 area of the base, 3 squared times pi, and then the height of the cone is 5. And so it's going to be 1/3 of 9 pi times 5. 1/3 of 9 pi is 3 pi, and it's going to end up equaling 15 pi. So again, the volume of the cylinder is 90 pi. The volume of the cone is 15 pi. So the volume of the composite shape is 105 pi centimeters cubed. And you can leave your answer in pi unless otherwise requested.